In this experiment, we will work with cobalt complex ions in an equilibrium reaction. The goal is to cause disturbances to the equilibrium, shifting the reaction forward, backwards, or causing no change at all. We will use the solution's color to tell which way the reaction has shifted by applying our knowledge of the Chatlier's principle to predict these reaction shifts. In this lab, we'll only need a few reagents. We need a vial of anhydrous calcium chloride, a dropper of 6.0 molar hydrochloric acid, a little dropper of 0.1 molar silver nitrate, and of course, our cobalt complex prepared at equilibrium. Note the deep purple color that this has to begin with. We'll start off our setup by prepping our water baths at our two different temperatures. One beaker we have will be filled with water and placed on the hot plate to heat up to about 80 degrees C. We'll turn that on now. And then our second beaker, we'll fill it with water and add some ice to it to turn it into an ice bath. Once we got those water baths going, we can now pour out equal amounts of our cobalt complex to each of our 5 test tubes labeled 1 through 5. We'll leave number 1 as our reference tube, meaning this one we won't do anything with it. We'll just leave that one so that way we can compare all of the equilibrium changes to our control test tube. So we'll start off with test tube number 2, which will undergo 2 different temperature changes to determine the shift of the equilibrium. We have our hot water bath that just hit about 80 degrees C, and so now it's ready to go. We'll put this test tube in here. We'll leave it in there for about 2 minutes or so. Alright, so it's been about 2 minutes and you can see that there was some color change. If we compare it to our test tube 1, our control, you can see there's a pretty big difference there. We'll now add it to our ice bath and we'll see what happens then. And we'll leave that in there for about 2 minutes as well. Alright, so now it's been about 2 minutes. I'll take this out of the ice bath here. And you can see we got more of like a pink color when we compare it to our trial 1, our reference tube. So these are our temperature dependent reaction shifts. Now to test tube 3, we're going to add about 10 drops of our 6 molar hydrochloric acid. So that's about 10 drops. Alright, like I said, we're leaving number 1 so that we can compare the colors. We can see what happened to the reaction. We can see which way it shifted. So now what we're going to do is we're going to take some of our DI water and we're going to add about 1 ml of this and then see what happens. So now we see that it changes color again, right, compared to number 1. And we can determine which way the reaction shifted. And then adding a little bit more water, we can continue to see how much that color continues to change more and more pink. All right, now to test tube 4. We're going to start off by adding some DI water to it right away, about 2 mils. And just like test tube 3, we see the expected reaction change. But this time we'll add some calcium chloride. We'll add like a scoopful, a small scoopful of it, and we can see what happens right at the bottom of the test tube. So you can see here at the bottom of the test tube, the calcium chloride has kind of turned blue while the rest of the solution remained pink in comparison. If we add more calcium chloride to it, we'll just see that it continues to compile there at the bottom. And it stays blue there at the bottom. Finally, to test tube 5, we're going to start off by adding some of our hydrochloric acid. Again, about 10 drops. Give it a quick little shake. Obviously, again, make that color comparison. And then we're going to add about 10 drops of our 0.1 molar silver nitrate to this one. So now what's different about this one as compared to the other ones? We can see that it's kind of formed a gradient there, and it looks a little cloudy-ish with some salt falling to the bottom of that test tube right there. So here we got test tube 1, right? That's our reference. It's test tube 2. This one I just heated it back up. We got test tube 3, where we added hydrochloric acid and water to bounce it back and forth. And then number 4, where we had added our calcium chloride, making observations, see how they're different, how they're the same, and why they're different.